Hey everyone, welcome to tutorial number 11. In the next few videos, we're going to take a look at how SuperCollider integrates with the Open Sound Control Protocol, more commonly known as OSC. In contrast to the MIDI protocol, OSC is faster, more flexible, more time accurate, and doesn't include a hardware specification. OSC messages are most commonly sent over the internet, taking advantage of established net transmission protocols such as UDP and TCP. The syntax of an OSC message consists of a URL-style address followed by some number of arguments. Often these arguments are numbers, but not always. OSC messages are sent to a specific IP address on a specific port. In this video, I'll be using TouchOSC, which is a multi-touch interface designer for iOS and Android. You can find some links and resources in the video description. So let's open TouchOSC. Right now, we're looking at the main settings page, where you can set up your OSC connection, choose an interface layout, and some other things. In the layout list, you can view the available layouts. Tap the one you want, I'll choose Jog On, and then hit Done in the upper right corner to bring it up. All the controls on this layout send OSC messages, but they won't do anything right now because I haven't set up an OSC connection. You can return to the main settings page by tapping the button in the upper right corner. In many cases, you'll probably want to make your own interface. You can't actually create or edit layouts within the TouchOSC app. Instead, this is done in a separate application called TouchOSC Editor. Since I'm using an iPad, I'm going to select the iPad layout size and choose a horizontal orientation. Right-click or control-click on the canvas to bring up a list of available controls. And I'm going to keep things simple and just drop a few things onto the canvas. I'll grab a toggle button, 2 H faders, and an H rotary. You can move and resize controls by clicking and dragging. Holding Shift while dragging preserves the height-width ratio. And you can also copy and paste just as you would with a normal text editor. If you click on one of these controls, a panel appears on the left side of the editor, where you can change the color, the numerical output range, and various other parameters which are specific to that control. For example, I can change the rotary to be centered. If I click on the canvas, we can see that the name of this particular page is simply the number 1. Clicking on the toggle button, for example, you can see that the address of this control is /1/toggle1. This is the URL style address that I mentioned at the beginning of this video. You can uncheck auto and give your controls custom OSC addresses if you want, but they must start with a slash. If I click on the page and change its name, then the controls addresses are automatically updated to reflect the new page name. In this case, the new address is now /main/toggle1. To add a new page, right-click on the canvas top bar. The name of this new page defaults to the number 2, so if we add a control on this page, its address would be /2/fader3. Let's stop here and save this interface, and I'll name it Basic. Make sure that you save your new layout in the TouchOSC Layouts folder. After saving, we need to synchronize this Layouts folder with the TouchOSC app. At the top, click Sync, and a window with step-by-step instructions appears. The first thing we need to do is make sure the computer and mobile device are both on the same network. I can see in the menu bar that my computer is on my home network. And I can verify that the iPad is connected to this same network. So that's the first step out of the way. The next thing we need to do is go into the TouchOSC app and navigate to Layout and then Add. On this screen, sometimes available TouchOSC hosts will pop up automatically, and sometimes they won't. In this case, I could just tap my computer's name. If you don't see your host computer, touch Edit in the upper right corner, then the plus sign in the upper left corner, and you can enter the computer's local IP address manually. On macOS, in System Preferences under Network, I can check my local IP address, which happens to be 192.168.1.5. So back in TouchOSC, I simply enter this IP address, hit Enter, and then tap the IP address that appears. And now we can see that our basic layout has been added to the layout list. Select it and touch Done. Okay, so with that out of the way, let's read this OSC data into SuperCollider and just print it in the post window. For this, we use one of two objects, OSC-func or OSC-def. Since I used MIDI-def in tutorial number 9, I'll use OSC-def for the sake of consistency. But first, we need to boot the server, since it is the program which actually sends and receives OSC data. Before we move forward, I want to draw your attention to the help documentation. Under Browse, External Control, and OSC, here we have a handful of relevant files. In particular, I suggest reading the guide called OSC Communication. I'm going to make an OSC def that will respond to OSC messages coming from the toggle button on the TouchOSC interface. The first argument is a symbolic name, which can be whatever we want, and next we need a function to be evaluated when an OSC message is received. As was the case with MIDI-def functions, an OSC-def function also allows for a specific collection of input arguments. The OSC-def help file reads, when the function is evaluated, it will be passed the arguments message, time, address, and receive port. So, let's create 4 arguments for this function, enclose them in an array, and just plan on posting them. An OSC-def also needs the URL style address, corresponding to the source of the OSC message. We can see from the TouchOSC editor that the toggles path is /main/toggle1. We provide this address to the OSC-def as a symbol. But if we create a symbol using the / approach, like usual, SuperCollider has trouble with this, syntactically. Instead, we forego the / syntax and use the alternate syntax of enclosing the address in single quotes. This is generally enough to get OSC-def to behave the way you want. But there's one last step. We have to jump back to TouchOSC and establish the OSC connection from that side. First things first, on the main settings page, we need to make sure OSC communication is enabled. Next, we need to specify the IP address of the host computer, which we've already looked up. Next, the outgoing port should match the port that SuperCollider is listening to. By default, SuperCollider listens for incoming OSC data on port 57120. We can verify this by evaluating netaddress.langport. Next, we need the incoming OSC port, and since we're not planning on sending data to TouchOSC, this doesn't really apply. And last is the local IP address of the mobile device. In some cases, you might have data coming from multiple OSC sources, in which case it might be necessary, or at least useful, to take note of these different IP addresses so that you can separate out different streams of data. But again, in this case, it's not really necessary. Let's go to our saved basic layout, jump back to SuperCollider, and finally, let's evaluate the OSC def. Now, if I tap the toggle button on TouchOSC, we'll see the corresponding OSC data appear in the post window. So, the hard part's over. We're looking at all the data from the toggle button, including the address, the time received, the IP address of the source device, and maybe we don't want to see all that data. If we only want to see the OSC message proper, we can just remove the other arguments from the function and reevaluate. Notice that the message argument is itself an array, which contains the OSC address, followed by some number of numerical values. Of course, in this case, it's just the one toggle value. So if we only want the numerical arguments, but not the message address, we can ask for the item at index 1 within the message array, like this. So that's looking pretty good. I'll make 3 more OSC defs for the remaining 3 controls. One for the first fader, another for the second fader, and one for the knob. And now back on TouchOSC, here's the toggle, fader 1, fader 2, and the knob. So everything's working. And now we're in a good position to start using this data to make sound. So I'm going to quickly construct a synth def. An ADSR envelope will control the amplitude of the sound, and the gate will be closed by default. The source of the sound will come from blip, which generates harmonic partials. I'll set a fundamental frequency, and to create a detuning feature, I'll multiply the frequency by a slow-moving LF noise 1, ranging between negative and positive detune values. I'm envisioning detune as a number of semitones, so I'll use MIDI ratio to make the output values suitable for frequency scaling. I also want to add a second argument to blip for the number of harmonic partials to generate. For additional complexity, I'll adjust the amplitude by another slow-moving LF noise 1. I'm going to multi-channel expand these two noise generators by 16 so that the source sound becomes an array of 16 blip generators, each with a uniquely meandering frequency and amplitude. But since we don't have 16 speakers, I'll use splay to mix the 16 audio channels down to stereo. Next, I want to be able to balance the left and right channels independently. But I can't use pan 2 because pan 2 expects a monophonic input signal. Instead, I'll use balance 2. Balance 2 expects the left channel, which I can specify as sig at 0, the right channel, sig at 1, and the pan control. Apply the envelope, apply the master amplitude argument, and output the signal. And now just a quick test to make sure everything's working. Alright, so using TouchOSC, I'd like to be able to control these parameters: gate, frequency, detune, number of harmonics, panning, and amplitude. So that's 6 parameters, but right now I only have 4 controls on the interface. Fortunately, if you've got the TouchOSC editor up and running in the background, modifying layouts is pretty quick and easy. First, switch over to the TouchOSC editor and make the desired changes. Save the layout, and then click Sync. And on TouchOSC, go to the layout list, tap Add, select the host device, and it'll ask you if you want to overwrite your previous layout. Tap OK, go back to the main settings page, and tap Done. Now, first thing we need to do is add 2 more OSC defs. And then modify the functions of all 6 OSC defs to control the synth. I'll have the toggle control the gate. The first fader will control the frequency, but right now the fader ranges between 0 and 1, and these aren't suitable frequency values, so I have to map this normalized output to a new range. You can do this in TouchOSC or SuperCollider, whichever you prefer. I'll have the second fader control the number of harmonics, the last fader, the overall amplitude. Now technically I don't need to map these values, but I prefer an exponential range of amplitude values instead of a linear one. The centered knob will control panning, and the last knob will control detuning with a maximum of 12 semitones. And that's about it for tutorial number 11. In the next few videos, I'd like to demonstrate how to use SuperCollider with the Nintendo Wiimote, as well as the Xbox Kinect. So, stick around for more OSC tutorials. I also want to say a very genuine thank you to all the viewers and subscribers. I've gotten a lot of positive feedback on these videos, and I'm very happy to know that people are finding them useful and enjoyable. So, thanks for watching. See you next time.